Hi, here we are again, back in my basement. It's only 9:30 tonight. I was up last night until 11:30 doing your lecture. I decided to start off with video because in this particular world that we now live in, um, seeing people's faces, seeing people even recorded is important. I just went back on Facebook for the first time in 4 months. I quit Facebook because I just couldn't handle an app that told me how to be angry and told me who was angry at me. Um, I'm back on Facebook just so I can reconnect with friends, stay connected to people, and be able to um, find out what's going on out in the world. Because quite frankly, I'm going to be here in the house for, the plan is at least a month. Um, a month takes us out to April 17th, which is when we're supposed to be back in school. Um, I have my doubts if we will be back to seeing each other face to face at that point. It depends on how much we flatten that curve. And if we can flatten the curve, if we can stay under the capacity for hospital beds and ICUs and ICU beds, vents, um, then we might have a shot at it, at being back in school and still having commencement. Um, with that all said, um, I'm going to shut off the video um, and we'll go to just shared screen stuff like I have done for the past couple of days. We're going to have just a couple of PowerPoint slides, and then I'm going to go back to that example code that I started working on yesterday. And we'll finish that off today, and we'll talk about what's going on a little bit while we're doing it. So pay attention not just to what I'm writing in code, but to what I'm saying. So a good way to watch this video and the latter 2/3 of yesterday's video is to pause, write down the code, maybe go back and listen to what I'm saying as I'm writing the code. To get better insight into the thought process and into how we build these classes. So I'm going to freeze video now, and you'll still hear me, and you'll see my PowerPoint slides. So I'm going to share my PowerPoint slides for today. Okay, and so we're going to continue now with classes. Now, when we continue on our introduction to classes and abstract data types in C++, I exchanged some email with one of you. I think it was earlier this morning about reading. Okay, I've said some things verbally about reading. You know, read this, don't read that. Read this only for the high level idea. Don't read it for the specific implementation. And so what I've done is I've laid out the best subsections to be reading, and I think I've covered to the end of the semester. So, you know, copy these down someplace, mark them in your book, do whatever. But these are the sections that we'll be reading that will support the topics that we're covering. So, so you're reading 10.1 covers structs, and you'll need those structs from here on out. Even when we're building classes, those linear data structures, notice how structure and struct have the same root word. That's how you build data structures, is with structs, even if they're inside classes. The book does the building of those data structures a little funkily. I'm not sure I agree with the way he does things. In fact, I know I don't agree with the way he does things, but most of that content is, you know, germane. And the thing is, you know, there are an infinite number of ways to write any program in any language. And so everybody has their own particular twists and turns in the ways that they like to do these programs. So read 10.1 for the structs. You want to read 10.2 and 10.3 for an introduction to classes. And that's what we're at right now. We're doing that introduction to classes. And so 10.2 and 10.3 are exceptionally relevant. I just started using if no def, if ndef in the C preprocessor, and that's in 12.1. I also started using call by ref, and call by ref is in 5.2. So read 5.2, look that material over, and then go ahead and read 5.3 and 5.5. Then we're going to return back to the linear data structures. So that's 13.1 and 13.2. But that when you first read these two chapters, just pay attention to how the data structures work, not how they're implemented. We'll get to class-based implementation for those linear data structures, but right now your struct program is not using classes. We're only using structs, but that stack is going to work the same way. So think about how these work, not about how they're implemented. Now, the reading on to the end of the class, on to the end of the semester, you're going to read 11.2 and 11.3. And those include some ideas that we're going to have to use, particularly when we get to linked lists. Then I'm strongly suggesting that you go back and reread sections 13.1 and 13.2. But this, at that point, this will be when we're deeper into classes. And now you can pay attention to the implementation. How does this get implemented? Understanding that my implementation approach and Savage's implementation approach are slightly different, okay? And then, strangely enough, I want you to read appendices 7 and 8. 7 is the idea of the this pointer. This is a context idea. This means in the current object, or the object that I'm in. When we say objects, we're talking about a physical thing, a thing with memory and allocation whose type is a class. So when we say classes and objects, we're really talking about types and variables, if you want to think about it that way. You know, that parallel int is a type. I is an instantiation of that type when we say int I, semicolon. And so classes and objects work the same way. Classes define the type. And then when we declare variables to be of that type class, those we refer to as objects. And so the this pointer is used inside of those objects to say this particular instance, this particular object. Just like we say I is a very particular int. It's not J, it's not N, it's not M. It's I, it's this, okay? And then chapter 8 has overloading of operators. And we're definitely going to do some operator overloading. We'll overload the stream insertion and the stream extraction operators. And we'll also overload relational operators when we get to linked lists. And so that's a lot of stuff to come at you. So you want to keep up with that reading. You want to read those appendices, and then go back and read 14.1 and 14.2, or 14.1, 14.2, and 14.3, okay? Now, I'm going to return back to that wireless sensor networks example. This is just a class for defining a wireless sensor network node. And we don't know how these nodes are going to get stored. We don't know how, you know, I could create an array of these nodes. I could create a stack of these nodes, but that would require some other code going on that uses this particular data type that I'm defining. And so Now I'm going to drop the share of PowerPoint, and now I'm going to share. What the heck is going on here? Well, I'm trying to figure out what's going on. I seem to have lost a window that I had up that I wanted to have up. And the share isn't showing me that window. Okay, here we go. I finally figured it out. Hey, it's a learning curve for everybody. It's a lot of trial and error. Last time, if I just type out sensor.h, this is the specification for the class sensor. It has a lot of stuff going on in it. And mainly that's because of our getters and setters. Getters and setters are right down here. There's our setters. Those are what we call accessors. So I prefer the term accessors and mutators, but the short, a lot of people will use getters and setters. So getters are accessors, setters are mutators. And so these are our mutators. These are our setters. And they allow us to set the data, the private data members with values. And we do so safely and securely. So that means we're going to make sure that the data that we're putting in there is valid. So we're going to do range checks on latitude and longitude. So latitude varies from -90 to +90 degrees. So you can't go outside of that. And if somebody tries to go outside of that, we're actually going to issue an error. Same thing with longitude. Longitude goes from -180 to +180. And so again, if we're outside of that range, you're going to get an error. We don't actually error check the readings because we don't know what these readings are. Maybe it's temperature, maybe it's humidity. I don't know. I just made it up. And so in that case, I'm not going to do any range checking on those. IDs, certainly IDs are have a valid set of values. Those are positive. And whenever I've done wireless sensor networks in the past, we've used integer ID numbers starting at 0. So sensor 0, sensor 1, sensor 2. And the reason we do this is because then they correspond nicely to an array of sensors, but they could also be used to do a linked list of sensors or a binary tree of sensors. It doesn't matter, okay? Now, I also have my getters, and my getters here allow us to retrieve that data from inside the object. And so I've defining this class. I'm going to declare some variables that are of objects that will be objects of this type. And so get ID allows me to retrieve the ID from inside that object. Get latitude, get longitude, those similarly allow us to get the latitude and longitude. Get reading is a little bit different because we have 5 readings in here. Basically the 5 most recent readings. And so let's talk about that for just a second. The 5 most recent readings, 0, it's going to be an array. And if I change max readings to 10, it'll be the 10 most recent readings. If I change it to 3, it'll be the 3 most recent readings. Okay, so the first slot in the array, index 0, is the most recent reading. So when I get a new reading, when I'm using that setter, I'm just going to shuffle everything down in the array, and I'm going to get rid of the last reading in the array. And so get reading, similarly, I'm going to have to say which reading I want. 0 would be the most recent, all the way up through max reading -1 being the least recent. But I've got to range check that index that I'm passing in to get reading. And so we've got to be careful that we don't walk off the end of the array, that we have a buffer overrun problem. Okay. And then there's one last member function, one last method that's called print sensor. And sometimes we're just going to want to print out all the information from a sensor. And that's what that method is there for. Down in our private, we have the private data. Okay. Now, when I first did this on the whiteboard, I was planning on doing this with a linked list. I backed off of that. So there's no next and there's no struct here. It's just the data for the sensor. Okay. And then I started writing that code, and that's where I'm going to go right now. I'm going to go back into sensor.cpp. Okay. And in here, all I had created at the end of yesterday's lecture was the constructor and the destructor. Okay. And then I had created set ID. So set ID was the first mutator that I had written. So now we're going to write the rest of those mutators. And just to keep track of where I'm going, I'm just going to dump them all in here at once, empty. And then I'll go back in and fill in the code. So remember, I have to do void, because these were defined to be void. I've got the class name, which is sensor. So that's the namespace this is in. Then I have the scoping operator, which is 2 full colons. The name of the function, which is setLat in this case. And then the parameter to that function, which is the latitude value that we're going to dump into the private data member inside the class. Now, I'm just going to put in a blank function here. This is a function stub. And for now, that's all I'm going to do. I'll really come back and fill in that code later. But what I want to do is put in all of these functions, these member functions, so that I don't lose track of them. Okay. And so what you can't see is I've got a list of all the functions I need to write right beside me. And so I need to write, I just did set lat. I also need to do set lon for set longitude. That's going to have a double longitude as a parameter. Same thing again. Just an empty function for now. And then I've got a, what have I got here? I'm looking at my list. Setlon, again, class name, which is the namespace or the context, sometimes we call that. The scoping operator, so inside the class sensor, we are going to have a function called set new reading, okay? And that just takes a single double as a parameter called new read. And so when we write this function, this is where we're going to shuffle the measurements or the readings in the array, putting that new reading in at array index 0, and shuffling all the current readings down by one, with the last reading being thrown away, essentially, because it's too old. Okay, now we've got our getters. So these are our functions that go into the object and pull data out for us. And so those have to be scoped again in the class. And get ID, okay? And strangely enough, we can just write these. These are so simple that there's no reason to not write them right now. That's it, done. Get ID is done. See that? All it does is return, so we're inside the object right now. We have access to the private data members, and all we're doing is returning the value of the private data member lowercase ID, okay? So that relies on us being inside of the object. Similarly, we have a function that is of type double that is called, getLat. Okay. No parameters to this function, just like the getter up above. And again, this is just return, and then we're inside the object, so we can access that private data member directly. If we were outside the object, if this was just code running in our main, we couldn't do this. We could not access those private data members. It would cause a compiler error, okay? So there's getLat. Similarly, we have a function scoped inside of the class called getLon, okay? And that's just going to return lawn out of the inside of that object. Now I'm going to stub out the next two simply because there's more code that goes into get reading. Okay, still scoped inside the class. So there we are, we're scoped inside the class. The function name is get reading. And it does take a parameter, and it takes the parameter of read num. I could have called this index, I guess, but this is the number of the reading. And for this thing, this one's a bit more complex. And so I'm just gonna put in a return of -1 at this will be right at the bottom of that function, but we'll have a lot more code to put in there. And then the last function we have is of type void, scoped inside the class. So this is a function, this is a member function, this is a method, and this is called print sensor, okay? And print sensor is just going to print out the sensor in a nice way. And this actually was in our example code from what seems like 2 weeks ago, but it was really just on Monday, I think. No, it was on Tuesday. Wow, it was just 2 days ago. And yet it seems like it was 2 weeks. Pandemic time, everything is expanded. It just, each day seems so long. So this code was back in those example programs that I wrote 2 days ago. And this code actually is pretty straightforward. We need a local variable I, okay? And then I really am just taking this from the code that I wrote a couple of days ago, dump the test data. Well, actually, it's not test data in this. It was test data 2 days ago. So I'm going to say dump the sensors data. Okay. And now it's a bunch of C-outs. So I'm going to C out sensor. And then I'm going to output the ID of the sensor. And then I'm going to put in an end line. So this is going to print out sensor colon and then the sensor's ID with space in between. The next C out is going to dump out the latitude. And I'm going to do something a little different here than what I did in the earlier code. I don't think I did this quite this way. I think I used tabs. I'm going to use 4 spaces. So just like I was indenting in code, and latitude, okay? Again, that colon space, and then lat, and then an end line, okay? Next line, exactly the same. So open up the string, give it 4 spaces so it's indented, longitude, colon space, close off the string, then dump in the longitude that's in the object that's stored in our private data, and then an end of line character. Then I'm going to have a C out, open up the string 4 spaces over, and I'm going to say readings, okay, colon, but this one doesn't need any space or anything, and in fact it just has an end line, because now all of those readings have to be printed out by a for loop. That's why I've got an I up there, okay? So for here, I'm going to say for I is equal to 0, I less than max underscore readings, okay? I plus plus. And then inside of here, I'm going to have a C out. I'm going to give it a tab space, or a tab, not a space, a tab, to tab it over 8 spaces. And then I'm going to dump out readings sub I. So readings is that array that's in our private data inside the class, inside this object. And then an end line, okay? So it's going to print those readings 1 per line. And when it's done, then we'll just return. We're done with this print function. It's a void, so we don't have to return anything. And I shut that off. Now, the reason I did print sensor is because it'll be useful in debugging things. In fact, given what I've just written, I should be able to compile and run an example program using just this. The functions, the member functions are stubbed out, so they'll compile. Everything should compile and run at this point if I've done everything properly. So what I'm looking at is a program called ex4.cpp, okay? And we're going to need to write that. And I'm just looking at my notes right now, okay? So in here, I'm going to get out of this file. I'm going to vi ex, is it 4? Yeah, 4.cpp. And this is going to have the standard stuff in main. So I'm going to include IOStream. I'm also going to include the local file sensor.h, our specification for our class. So this is how we bring the class in so that we can use it in our program. Set the namespace to standard. And then we have our int main. I need to set no C indent in VI here so that it doesn't automatically indent for me. And I'm going to define a temporary variable called of type sensor. And really, that's all I have to do at this point. Then I'm going to return 0. And that's it. So you might think, why this? I mean, really, you're just going to define a single variable? What the heck are we doing here? Well, this tests both our constructor and our destructor. So if the constructor and the destructor, remember, those are those special pieces of code in every class, have to be there. The sensor temp, okay, right up here, that sensor temp that I just highlighted, that invokes the constructor. When we return 0 out of main, it's going to invoke temp's destructor. And so this will actually test both the constructor and the destructor. So I'm going to get out and I'm going to compile this and see if this all runs. So I'm going to compile ex4.cpp. Now I also, and this is the first time, I think this is the first time we've done this, I can compile multiple files into a single program. And in fact, in this case, I have to. I am going to say sensor.cpp as well. And so it's going to take these two files full of code and compile them together. Now, sensor.cpp has all of our stuff in it for the class. That's the implementation of the class. And so those two together are going to allow me to use the class, okay? If I didn't do this, it's gonna give me a compile error. And it gives me a really strange compile error, but it's undefined reference to sensor, : sensor, that's the constructor, and an undefined reference to sensor, : tilde sensor, which is the destructor. Now those references are implied. They're implied when I define the variable temp, and they're implied when I execute the return ending main, and thereby needing the destructor for temp to run. That's why we get those errors. So if I add sensor.cpp onto that compilation, hey, everything runs. Look at that. And now if I execute A, I've got to wait for the stupid Avast antivirus, because it's like, ooh, this might be, this executable, I don't know this is bad. Well, there, it finally ran. Takes about 15 seconds each time I compile and run. So, oh, goodness. Too much talking these days. You know, most of the time I spend my whole day in my office, sitting at the computer, not doing a thing, not talking. And now I'm at home and I'm talking to my wife all day. So by the end of the day, my voice is like starting to get really scratchy. Okay, so that all worked. So I'm going to go back into sensor.cpp now, and I'm going to start doing the getters and setters. Okay, so down here, here we go. Let me pull up my notes again. So set ID, we're looking at set latitude. So that's the first one I'm going to do here. So right here, okay. No. There we go. Ah, there's that stupid C indenting again. So I get rid of that in VI. This is actually Vim, so it does some stuff I don't like. So on the indentation. And so here we go. So what do I need to do to set the latitude? Well, remember I said latitude varies from -90 degrees, which is the South Pole, to positive 90 degrees, which is the North Pole. So if, okay, now remember our parameter is called latitude. So if latitude is greater than or equal to negative 180, and latitude, spelling, is less than or equal to, wait a second, that's not 180. I said it right the first time and then just wrote it wrong. So negative 90, there we go. And latitude is less than or equal to 90, the North Pole, okay? So that means we have a valid value for latitude. And that means I can just say lat equals latitude, okay? Now remember, we're inside the object, we're inside the class. So lat, the private data member, is available to us. We can alter that, we can muck around with that. And so we're setting its value equal to the parameter, the value that was passed into the setLat function. Now we're going to do the else. And for now, we're going to do something that we probably shouldn't do in production code. And that is, we're going to just print out an error message. In production code, we would probably want to throw an error at this point. So there's this idea in C++ called try, throw, catch, and we would throw an error, and this allows for error handling. We aren't going to cover that right now. We'll maybe get to it at the end of the term, okay? So this needs to be an error, so it needs to yell nice and loud at the user who did this stupid thing. And we're going to say latitude must be between negative 90 and 90 degrees. \n for the new line, and shut that off. There we go. So that's our setter for latitude. What I'm going to do now is I'm just going to grab this code. So let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 lines here. So I'm going to yank 8J, and then I'm going to put that down in the longitude, okay? So going back into insert mode, and now we just say longitude is greater than or equal to 180, negative 180, and longitude is less than or equal to positive 180, then we want to set lon equal to longitude. And then I got to fix up my error message, because the error message says latitude, longitude must be between negative 180 and 180 degrees, okay? I hate retyping code. If there's code that I can alter, you know, copy, paste, and alter, that's what I'm going to do. So that's what I just did there. And so now our setter for longitude is done. Here comes the hard one, the confusing one, the one that's just not as nice as we would like it to be, okay? I'm going to need an integer. Now remember, I've got a new reading, a brand new reading. That new reading goes into the reading array inside the class. So it goes into slot 0 of the reading array, and everything else has to be shuffled down. So it turns out the easy way to do this is to shuffle from the end back to the 0th position and then dump in the 0th position when we're done. So this for loop, you're going to want to spend some time with a piece of paper and a pencil and draw pictures and walk through the loop to see what it does, because this is not going to be obvious to you as new programmers or relatively new programmers. So I'm going to start at the end. So I'm going to start at I equals max readings minus 1. Okay, so I have to do the minus 1 because remember, max readings right now is 5, but that means that the array indices are 0, 1, 2, 3, 4. So we need to start at 4, that is max readings minus 1. Okay, and then we want to keep running as long as I is greater than 0, not greater than or equal to, but greater than 0. I minus minus. So that means we're going to start I big and take it down. So we use the decrement operator instead. Like I said, you're going to want to spend some time with a piece of paper, a pencil, make a table of values or draw pictures of the array and figure out exactly how this for loop does what it does. And this critical piece of for loop is exactly the same as the for loop. Well, pretty much exactly the same as the for loop in the inner for loop in a thing that we call insertion sort. And so this is used in an algorithm, this same sort of loop, backwards running loop, okay? Bubble sort does this as well. It has a backwards running loop. And so readings sub I is equal to readings sub I minus 1. So what this is going to do is it's going to reach into the array and copy it back. So first time through, if max readings is 5, the first time through I is 4, and it's going to say the 4th reading slot is set equal to the 3rd reading slot. Okay, so it's copying that back. Okay, that's it. That's all we had to do in there. The complexity here is in the setting up of the for loop so that it does everything that it needs to do correctly, and so that it doesn't do an off by 1 error. The off by 1 errors are in the initial setting of I. You need that max readings minus 1. If you just did max readings, that's an off by 1 and you run off the buffer. And it has to stop when, before I is equal to 0, because then that I minus 1 in the reading sub I equals reading sub I minus 1 would again be an off by 1 error, okay? And then the only thing we have to do after this loop is done is take care of the 0th slot. And that one's just going to be set equal to new read. That's where our new reading goes in. And now we have set this up so that the most recent reading is at 0. The second most recent is at 1. The third most recent is at 2. Fourth most recent is at 3. And the fifth most recent is at index 4. If I change it, if I change max readings, I don't have to rewrite any of this code. It all takes care of itself. And that is why we use const ints for the sizes of our arrays, the sizes of our strings, all of those things. Okay, continuing on. Get ID, get latitude, get longitude. Oh, get reading. So here's code that we needed to write. So I'm going to scroll this up a little bit so I got some room so you can see what's going on. For get reading, I need to do a range check. Okay. So if, that's how we do our range checks. Read num, that's the parameter. If that is, oops, greater than or equal to 0, and read num is less than max underscore readings. So basically this checks and tells me if I have a valid index into the array. So if I do, I'm just going to return readings sub read num. Okay, and then if read num is outside of that, I'm going to output an error. And this error message is kind of long, so I'm going to break it into 2 lines or 2 different couts. Invalid reading number, reading numbers, \n cout. And then I'm going to use a tab character to tab over the rest of this error message so that the error part of the message sticks out. So the \t gives me that tab. Must be between 0 and, give it a space, close it off, and then give it max readings -1 and an end of line. So the error message tells the user exactly what's going on. Now I'm getting oh, there's where that's being caused. I'm like, why am I highlighting all this stuff in red? Vim, which is what I'm running right now, not an editor I would suggest that you learn, but Vim keeps track of all of the parentheses, curly braces, square brackets, all that stuff. And so it was telling me I had something mismatched, and I didn't realize I had put in a random left square bracket. So I think I'm done. I'm going to get out of here. I'm going to go back into ex4.cpp. That's our test program. And I'm going to put some more code into our test program. Okay. So up here, I'm actually going to do temp.print sensor. And that's going to show me if my constructor actually zeroed everything out the way it was supposed to. Then I'm going to write a little message to myself. So I'll put this. Testing the mutators. And then I'm going to do temp, temp set ID. Okay. -12. That should produce an error. Temp.set ID 42. That should work. Temp dot. Remember, the dot operator gets you inside the object. Temp is an object of type sensor. So temp dot allows you to get inside the object and access anything in public. You can't access the private data, but you can access all of or use all of the public stuff. So set latitude, okay? And for this, we want to check on both ends. So we want to do negative 90.01. That should produce an error. Temp.set lat 90.01 should produce an error. And then temp.set lat 47.3 or 2365, and that should work. Okay, so we should get error, and then nothing, because nothing prints out when we successfully set one of those. I'm going to do the same thing with longitude. Temp.set lon. Remember the boundaries on that. We're negative 180, so I'm just going to go outside of that boundary to produce an error. Temp.set lon, just outside the other end of the range. So 180.01. And then I'm going to do a successful set longitude. And we're going to have negative 87.4281. Okay. And I've decided that really what I want to do is, instead of just saying testing the mutators, I'm going to say testing set ID. Okay. What's the matter, Gus? For those of you who can hear him, that's my cat, Gus. He came down to the basement studio to say, "What are you doing? What's going on down here?" Yeah, I know. So, then I'm going to do the same thing. I'm going to put a C out here and say testing set lat. I'm going to put in a blank line here just so I can pick out what I'm doing. Testing set lon. Just noticed I missed a capitalization there. So that's my set lon. And then testing set new reading. Is that right? Did I spell that right? Yep. Set new reading. Awesome. And \n quote. And then temp dot set new reading. And we don't have any range checks on reading. And so that means I really don't have to worry about it. And if I turned on my video right now, you would be able to see my cat because he's up on the table looking at the camera. And then he just ran away because he's a cat and suddenly he had to be upstairs. So set new reading, it doesn't matter what that reading is. I'm just going to put 89.5. And now I'm going to do temp.print sensor yet again. Okay. For now, that's really enough enough testing to see if things are working the way I think they should. And if this all works, I'm going to come back in and quickly put in a bunch more set readings with print sensors so that I can test to see that it's rolling those readings through the array the way it should. So let's get out. Let's compile this. I've got an error. Error, where is that error? Line 99. I don't think I have that many lines in there. That's because it's not in that file. It's in sensor.cpp. Clearly, I did something syntactically wrong in sensor.cpp. I need to go to line 99, which is right there. Oh, remember when I had that problem and I had a square brace? That should have been a curly brace. There we go. Now let's try it. Hey, let's run a.out for if you're on a Linux machine. I'm on a Windows machine, so it's going to be just a.exe. Okay, so I see all my zeros. So right up here, I see all my zeros. So my constructor worked correctly. Here I am testing set ID. ID must be a positive number. So I got the error that I was expecting. Then testing set lat, and there's the two boundary checks that produced errors. Then set lon, and the two boundary errors. Okay. Then set new reading, and there are no errors there. And then a dump of the sensor, and that 89.5 is sitting right at the top of the readings. My longitude, my latitude, and my sensor ID all worked. So my setters all were working. So let's go back in to that file right here. I'm going to go down here, and I really don't have to do all of this testing anymore because I know it works. And so I'm going to remove the testing prompts and the error conditions. Um, '89. Stop that stupid dinging. 78, 67, 56. Yeah, 45, 34. Oops. Okay. So here I've got 1, 2, 3, 4, 5, 6. So I should be able to see the readings walk off the end of the array in print sensor because I'm doing print sensor each time. So in case you couldn't tell, yes, I did spend like a year in independent software test. I am very, very anal about the way I test code. Okay. So I'm waiting for the virus scanner. Here we go, sensor 42. I'm not sure why I'm still getting this. Please move window away from shared application. I don't know what this means. Zoom is doing weird things on me right now. Okay, so here's our first pass, right? Here's our second pass. And sure enough, we see 78.5 come in ahead of 89.5. Here's our, whoops, where am I? Here we go. So there's the 78.9, there's 67, still got the 2 zeros in here. There, okay. Then there, and now we should see it drop the 89.5 off the end, and sure enough, it did. So all of that works. I really think that's about it for tonight. I think I'm probably done on time. So I'm going to stop the share. I'm going to turn on the video again. And here I am back from video. My brain tells me this has been about 50 minutes. And so again, here's your book, read your book. Here's a stupid thing you can do in Zoom. I can do virtual backgrounding. And in fact, I can do it on my shirt. I just like this. This is kind of weird. So, you know, there's something to go home with to give you nightmares if you're watching this late at night. I could also do, San Francisco Bay Area. That's always cool. Space, the final frontier. Okay, so, you know, I'm a computer vision person. What can I say? With that, we are done.